Hi, welcome to Number Club. This is Year 1 Pure, Chapter 3, Lesson 6. This is Inequalities on Graphs. This is the last lesson for this chapter, so get cracking. We've got on the grid, shade the region satisfying these things. Now, you should recognise from GCSE, really. There are a few things that you need to know. Greater than or equal to or less than or equal to requires you to draw a thick line, just a proper line, okay? Whereas greater than or less than are dashed. Okay, the way that I remember that was if it's got a line, draw a line. Okay, nothing too crazy. If you've got y is greater than, you're looking for the region above whatever line or curve you've got. So for example, if you had a U shape, y is greater than would be that section up there. If you had a line, then you've got that section up there, okay, above it. If you had, say, a cubic, you probably haven't seen many cubics just yet, but you'd have something that goes that way above. Y is greater than, you should be looking at the grid lines and going vertically above it. Okay, sometimes people can find that a little bit confusing. On the grid, shade the region satisfying y being greater than or equal to 1. So greater than or equal to means I'm going to draw a straight line. Y equals 1 would be this line here. Okay, obviously you should use a ruler. And we want that side and not that side. Okay, you can try and shade in like the correct side if you want to, but the thing is that you're going to end up drawing a couple more lines, and so it can be a bit confusing. So what I tend to do is just put which side I want and which side I don't want and work from there. Next, we've got y. If we had y is equal to x plus 2, we would have something that dashes like this. Okay, so I'm going to draw my dashed line and then I'll decide which side I want in a bit. Obviously, it might take a little bit longer over that depending on the difficulty of the actual line itself, but for me, I'm just going to draw a dashed line like that. It'll be a little bit easier for you as well because you'll be using a ruler, and I don't have a ruler setting on this thing. So we've got y is below x plus 2. So below will be downwards. Look at the line, head downwards. We want that side there. So we want this side, but not this side. Okay, and so far we know that we want something that's in here somewhere. We're not sure where. And we've got y is less than or equal to negative 2x plus 8. Now, you might find this a little bit more difficult to draw, and so what you might want to do is to put some values in for x and put some values in for y. I'm going to go with 0, 1, 2, and 3 just to get the idea of it. There's 8, 6, 4, and 2. Okay, so we get 0 and 8, 1 and 6, 2 and 4, 3 and 2, 3 and 2. Okay, and you can see how this is going to go. Okay, this is a less than or equal to, so we know that we're going to have a normal line, okay, not dashed. Obviously you should be using a ruler, and we want the bit where y is less than or equal to. So look at the line, pick a point, draw downwards. You want that side, so I want this side and not this side. So I want the bits that are above this line, inside this line, and inside this line, and so the region is this one here. Sometimes you'll be asked to put an R in there. Okay, it's really important that you do whatever's asked, so shade the region satisfying, and also make sure that you get dashed lines or thick lines wherever you need them. All right, moving on. Next, y is greater than or equal to x squared plus x squared minus 4. Now, I happen to know that this can be factorized, so I could use this information if I wanted to, okay, but the thing is that when you draw in this, it's going to be a bit awkward because you'll get those 2 points there, negative 2 and 2, and you'll also get negative 4, but you want a lot more information than that, really. So I'm going to go with x and y, values for x. So factorizing it's not really necessary, to be fair. You might use it for your substitution, but not many people would. Negative 3, negative 2, negative 1, 0, 1, 2, and 3. So when we've got negative 3 squared is 9, take away 4 is 5. Negative 2 squared is 4, take away 4 is 0. Negative 1 squared is 1, take away 4 is negative 3. 0 squared, take away 4 is negative 4. Negative 3, 0, and then 5. Okay, so we've got negative 3, 5. We've got negative 2, 0. We've got negative 1, negative 3. 0, negative 4. 1, negative 3. 2, 0. And 3, 5. This is a greater than or equal to, so we can draw a nice thick line through. Obviously, it's not that great in terms of my drawing here, but There we go. Make sure you hit all the points that you're supposed to hit. Okay. And you could even carry it on as well. 4 squared take away 4, it'll be up at 12. And so you could carry on that line just up as if it's going to hit 12 as well. Okay. So we get that. Now we want the bit where y is greater than or equal to that. So look at it, pick a point, draw upwards. We want that side. We want the bits in there, not out there. We want the bits in there, not out there. Okay, so we want this section here. Y is less than x plus 2. Now x plus 2 will be here. Okay, we've got a dashed line in this case because it's strictly less than. Okay, and what we end up with is something that looks a bit like that. Okay, we want the bits where y is less than, so down below. So we want actually this section in here. Okay, I'll put an R in there and I'll shade it, and we're done. Okay, nice and easy. It's just not much more scary, the fact that you've got quadratics involved. All right, here's an exam question on it. On the grid, shade the region comprising all points whose coordinates satisfy the inequalities, blah, 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 and blah, blah, blah. So we've got y is going to equal 2x plus 5. So we'll try out, we'll solve y is going to equal 2x plus 5. So we'll try out values of x. It only goes up to 6, and so you've got to be a little bit cautious about what you actually choose. So I'm going to choose, I'll choose -3, -2, -1, 0, 1, 2, and 3, and know that some of them won't fit on there, unfortunately. So we've got -6 plus 5 is -1, -4 plus 5 is 1, 3, 5, 7, 9, 11. Okay, so this is a less than or equal to, so it's going to be a straight line through. -3, -1, there, -2, 1, there, -1, 3, there. Okay, you can see the way it's going to go. 0, 5, it's going to go there, and we can carry on backwards as well, down to there. All right, nice straight line through, because it's not dashed. It would be dashed if it was just greater than or less than. This one's less than or equal to. And we want the bits where y is below that. So we want, from the line downwards, we want this side here, not that side. Okay. Next here, people find these ones a little bit difficult, but the way to deal with this, it's dead easy. Just make y the subject. It will make it a lot easier to deal with. So if you've got 2y plus x is less than or equal to 6, 2y is less than or equal to -x plus 6, y is going to be less than or equal to -1/2 x plus 3. It's not really worth kind of trying to draw this and then figuring out which side it is, because if the thing that people find most difficult about this is deciding which side of the line you actually want. So we'll pick out our values for x and y. We've got -3, -2, -1, 0, 1, 2, and 3. So we get 3, 2.5, 2, 1.5, 3.5, 4, and 4.5. So we'll get -3, 4.5. Now if this is 2, this is 3, this is 4, this is 5. So 4.5 will be in the middle there. Okay, just like that. -2, 4. -1, 3.5. There we go. You can see how that one's going to go in the end. Okay. One box across, half a box down. One box across, half a box down. One box across, half a box down. All right. There we go. Take a look. Is this going to be a dashed line, or is it going to be a perfectly? Is it going to be a dashed line, or is it going to be a thick line? Now, in my opinion, this one's going to be a thick line because we've got less than or equal to. Okay, so we've got a nice thick line through, just like that. Okay. Oops, could be better. There we go, like that. And we wanted the bits where y was less than or equal to. Don't worry about this sign over here. Don't think that that's important. Look at this one, the one that you've actually chosen to deal with. Y is less than or equal to. So we want the bits that are underneath. So we want that side and not that side. So currently we're working in this area here somewhere. And y has got to be greater than or equal to 2. So y equals 2 would be this line here. Much better, obviously, should be. So greater than or equal to will be the bit above, not below. And so you just want this bit here. That would be your region there. should really include that bit there as well. Okay, so that'll be your region. All right, work out the area of the shaded region. Now, to work out the area of the shaded region, you're going to need to figure out the width and the height of this triangle. Okay, now it's a little bit awkward this, because this was only 3 marks and this is worth 5, and it's not really part of this chapter, but we're going to have a go at it anyway. So the first thing is I'm going to try to find out that point there. Okay, now that point there will be the intersection between line 1 and line 3. So we've got 2x plus 5 is going to equal 2, 2x is going to equal -3, x is going to equal -3 over 2. Okay, so that point there will be -3 over 2, and y is going to equal 2 because it's on that line, y equals 2 there. Okay, let's figure out this point here. But in this point, we've got this one equal to this one. So we have 2y plus x is equal to 6 and y equals 2. Now that will be 4 plus x equals 6, just by substituting this into here. It's pretty easy. X equals 2. So we get 2, 2. Again, the y part is 2 because it's on that line there. And we need to find out the intersection point here as well. Okay, now the intersection point here is going to come from these two things being equal to each other. So if y is equal to 2x plus 5, but also 2y's plus an x are going to equal 6. So we've got 2 lots of 2x plus 5 plus x equals 6. Okay, I'll move it down here just so we've got a bit more space. 2 lots of 2x plus 5 plus x equals 6. That'll be 4x plus 10 plus x equals 6. We've got 5x equals -4, x equals 4/5. And when x equals 4/5, let's find out what y is. Y will equal 2 lots of -4/5, pardon me, plus 5. Y is going to equal -8/5 plus 25/5. Y is going to equal 17/5. Okay, so that point in there is going to be -4/5, 17/5. Okay, turned out we needed all 3 of those coordinates to be able to deal with that. Now let's talk about the horizontal of this triangle. So we've got a triangle that looks a bit like this. Now the horizontal of it is going across your x's. So we're going from -3 over 2 up to 2. Okay, so there's 2 and there's another 1.5. So the actual width of the triangle is going to be 3.5. And vertically it's going from 2 up to 17 over 5. So it's going from 10 over 5 up to 17 over 5. Okay, which is going to be 7 over 5. So to work out the area of the triangle, we've got 7 over 2, which is 3.5, multiplied by 7 over 5, multiplied by half. Half base times height, which is going to be 49 over 20 units squared. Okay, it doesn't say centimeters or anything like that. You could put centimeters squared and it'll be fine, but I'll put units squared. Okay, so that question there, the easy part was the inequalities. The more difficult part was all this simultaneous equation stuff, and you'll learn a little bit more about that when you get to coordinate geometry. But this is quite a nice way to have a look at it to start with. All right, thanks very much for watching. Hopefully you found it useful. Visit numberclub.org to find some more videos and tasks. Cheers.